Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss about the loss of head due to entrance and exit of the pipe. So this concept is coming under the minor losses in the fluid. So we know that the losses of energy is basically two types. One is of major losses, another one is minor losses is there. So major loss we can write already. We have discussed about this major loss, which is due to the friction factor, and in the minor loss we have several regions are there, like sudden expansion, sudden contraction, loss of head in the entrance and exit of the pipe due to bending in the pipe, due to sudden fittings in the pipe. So many regions are there for the minor loss. So this loss of head in the entrance and exit of the also is coming under minor losses in the fluid flow. So to understand this loss of head at the entrance and exit of the pipe, first let me consider a big reservoir or big tank, we can say. So here the water is supposed to be coming out from that tank, and this is the exit of the pipe, suppose. Now this tank is, or this reservoir is filled of some liquid. It may be called as water, but fluid. So here that water, actually what it is filled with, will have some pressure level. So this is our atmospheric pressure level is there. So here we can see this is P atmospheric is there, and the liquid which is present, let's consider this is water. Okay. Now if you see in this particular condition, now let me give, this is the reservoir. This is the reservoir, or we can say a big tank, reservoir or tank, and the liquid which is present inside this, let take that is water. Okay. Now, and this is nothing but the pipe through which the water supposed to supply from this container to different places. Now if you see, when the water is coming out from this container to this pipe, so how the flow will be flows through a path. So that, let draw it in this way. Suppose when the liquid is coming out from this container, you can see the liquid will become like this. Okay. So here, like the liquid will become because suddenly it is contracted here. You can see this liquid which is coming here. You can see suddenly the area of the, you can say area of this fluid, when it is coming from the reservoir to a small pipe, so area of this pipe or area of the flow is contracted. That means some compression is there in that area. So area of this, when it is in the reservoir, it is having a large area here. This is a large area is there, and suddenly it was changed to a small area. So that means area changed means here your velocity also will be changed. So this is the topic we already discussed previously. This is the case of when sudden contraction is there. So first one, for the entrance case, we can say for the loss of head due to the entrance, this will be considered for the sudden contraction in the pipe. So this one already we have discussed previously. So for this also we know what is the head loss is there. So we can consider the head loss due to the sudden head loss at the entrance. So that we can write H equal to, we know the formula, that is nothing but 0.5 V square, 0.5 V square by 2G. Okay. So previously it was V1 or V2 something is there, but here also we can consider the same, like 0.5 V square by 2G, what we have derived in the for previously sudden contraction case also. Okay. So this is about the flow when the liquid is coming out from a reservoir and it is flowing through a pipe. The same thing, entrance of the pipe. So this is the entrance of the pipe we have seen. Now when it is coming out, also some eddies formation will be there in this region. So this eddies formation will be make a losses during the pipe flow. These are the eddies. Okay. And as we have discussed previously, here vena contracta zone will be there, where the minimum surface area of the fluid will be there. So that is vena contracta CC. So this one already you've discussed previously, same concept will be there. So that one also you can refer that video so to understand more about the sudden contraction video. Now the same concept again, let's see one more concept here. So now second option, what is given? Exist of the pipe. So exist of the pipe, if you see, now see, this is the pipe is there. Now here it is going to be the what? The liquid is going to be exist from the pipe. So this is the loss of head due to, you can say, the velocity of the liquid, because we know that through the pipe the velocity of the fluid is flowing through that. So velocity of the liquid at the outlet. So this is the outlet. So you can say this is exist part. So water is, or the fluid is coming out from this exist or outlet. It is dissipated to the, you can say that means it is coming out from this pipe either in the form of jet, a free jet, like it is coming out from this. Okay, if you have seen some cello type things, there we can identify how the water is coming from the pipe with a high speed. So the water may be coming, or the fluid may be coming with a in form of jet if it is free, if the outlet is free, nothing is there in that. Or else we can say it is coming to the reservoir. Suppose from one tank to another tank, if you want to keep, so suppose some kind of reservoir may be kept, or some tank will be there here. So here also we can connect it. So that means both the cases, if you see, it is existing from the pipe. So this is our condition satisfied, existing from the, but existing of the pipe, if you see, now the pipe, if you see, now it is suddenly enlarged. The area of the pipe, you can see the pipe is same, the small pipe is there, but when it is coming out from this pipe, so flow area is enlarged here. So in this condition, what we can consider, the loss of head due to the exist of the pipe, we can consider that is H equal to, or you can say the exist outlet at the condition HO we can write. So this is nothing but V square by 2G. So this, the energy is lost in the reservoir. So the which energy, now when it is coming out from this pipe to a reservoir, so what are the energy is there at the outlet condition that is connected to a tank, suppose, or we can say any reservoir is there. So that energy is going to be lost at this point due to the sudden expansion here. Okay, and that is can be denoted by HO, and we can write this is V square by 2G. So V square by V is nothing but this is for this equation, and this is for this one, not this one. We can write, we can draw here. Okay, and here also you can write V is the nothing but velocity at the outlet of the pipe, and there we can write, here you can write V equal to velocity at the inlet of pipe. Okay, so this is all about the loss of head at the entrance and exit of the pipe. I hope you understand this concept. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you.